What is mathematical modeling? Mathematical modeling is the process of constructing mathematical models. In mathematical modeling, a real-world problem will be translated into a mathematical problem. We then solve the problem and interpret its solution in terms of the real-world problem. A mathematical model is a presentation of a system of scenarios that is used to gain qualitative and qualitative understanding of some real-world problems and to predict future behavior. There are a few important components in mathematical modeling. The first step is identifying and defining the problems. Number 2, making assumptions and identifying the variables. Then applying mathematics to solve problems. The next step is to verifying and interpreting solutions in the context of the problems. Then refining the mathematical models. And last, reporting the findings. Example 1. The grocery store which is far from your house sells a pack of 10 kg rice at a lower price than one closer to your house. Is it worth the drive for the cheaper deal? We can use the component of the mathematical modeling to solve the problems. First, we need to identify and defining the problems. The price of pack of 10 kg rice and the cost petrol. Determine the distance from the two stores to your house respectively, and find the information needed from each store from your house, the current petrol price, the car's petrol consumption rate, and so on. The step 2 is making assumptions. We can assume the road between the house, store A and store B is perfect straight line. We also can driving car to the stores and purchasing the same number and brand of rice as store A and store B. Identifying the variables. Let S equal to the distance between store A and store B. Let the P1 equal to the price of a pack of 10 kg rice at store A and P2 equal to the price of a pack of 10 kg rice at store B. M equal to the petrol consumption rate of the car in km per liter, and N equal to the number of packs of 10 kg rice to be purchased. H is equal to the current petrol price in Rm per liter. S equal to the difference in price in Rm for purchasing the pack of 10 kg rice at store B as compared to store A, and the T equal to the difference in the cost of petrol in Rm for driving to store B was compared to store A. Step 3. We need to applying mathematics to solve the problems. The price of a pack of 10 kg rice. Store A is 25 ringgit 95 cent and store B is 23 ringgit and 99 cent. Let the quantity of 10 kg rice to be purchased be 2 packs. The price to be paid with 2 packs of 10 kg rice at store A is 51 ringgit 90 cent and store B is 47 ringgit and 98 cent. Therefore, by purchasing the rice at store B, one can save 3 ringgit and 92 cent. Then let the distance between store A and store B be 6 km. The petrol consumption rate of a car be approximately 17.6 km per liter and the current petrol price be 2 ringgit and 8 cent per liter. Petrol need for the 6 km road is 0.341 liter. The cost of petrol for the 12 km roads is 1 ringgit and 42 cent. Therefore, we save 2 ringgit and 50 cent by purchasing 2 packs of 10 kg rice at store B. Step 4. Verifying and interpreting solutions in the context of the problem. The resulting mathematical model is as follows. S equals to P1 minus P2 times N, and T equals to S over M times H and times 2. If S more than T, then it is sensible to drive to store B to purchase rice and save more money. If S less than or equal to T, then we should not drive to store B to purchase the rice. The result of using the model S is 3 ringgit and 92 cents and T is 1 ringgit and 42 cents. Since S more than T, you save more money by purchasing rice at store B. Hence, it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. From the construct mathematical model, further exploration can be made. If all the variables remain the same, how far can store B be located so that it's an optimum choice? Use P1 to minus P2 and times n more than S over m times h and times 2. 25.95 minus 23.99 times 2 more than S over 17.6 times 2.08 times 2. S is less than 16.6 km. This means that if the distance between the two stores is less than 16.6 km, then it is sensible to drive to store B to purchase rice. What is the maximum price of a pack of 10 kg rice at store B that will attract a person drive to store B to purchase it? 25.95 minus P2 times 2 more than 6 over 17.6 times 2.08 and times 2. P2 is less than 25 ringgit and 24 cents. This means that if the price of a pack of 10 kg rice at store B is less than 25 ringgit and 24 cents, then it is worth the trip. Step 5. Refining the mathematical model. The assumption made regarding the road between the house, store A and store B is a straight line needs to be revised. If the road between the three places is not a straight line, how does this impact our model? If new assumptions are being made, then the model needs to be revised to reflect this change. Step 6. Reporting the findings. Use the symbols and diagrams when necessary to report the findings. The symbols and diagram will depict the whole modeling process until it leads to results. Every model has strengths and weaknesses. What is the important that the model identifies those strengths and weaknesses in the report? For example, the value of a person's time is not considered in this model. It is worth driving an extra 12 km for someone to save 2 ringgit and 50 cents. According to this model, saving 5 cents is considered worthwhile. The model did not account for any environmental considerations. Is it environmentally responsible to drive an extra 12 km just to save 2 ringgit and 50 cents? This model did not account for environmental efforts such as efforts to reduce carbon emissions. Example 2. The diagram below shows the cross-section of a river. A hydrologist measured the depth of the river Ym at different size x from the river bank. The results obtained are given in the following tables. Show how the hydrologist used the data above to determine the depth of the river through mathematical modeling. Step 1. Identify and defining the problems. How to determine the depth of the river. Step 2 is making the assumptions. We need to assume the river is the deepest in the middle with the depth decreasing to 0 at the edges. The two variables involved in this study are the depth of the river Ym and the distance from the river bank Sm. Step 3. Applying mathematics to solve problems. We need to write the distance from the river bank and the depth of the river as the set order pairs x, y and draw a graph for the data. The data seem to rise and fall in a manner similar to a quadratic function. The graph drawn shows the curve of the best fit and resembles the graph of a quadratic function. In mathematical modeling, to present the actual situation, the approximate value is used. Based on the graph, the depth of the river is 3 m when the distance from the river bank is 15 m. Step 4. Verifying and interpreting solutions in the context of the problem. Since c is equal to 0, the system of two linear equations in two variables is 1.7 equals to 625a plus 25b and 0 equal to 900a plus 30b. From 2, b equals to negative 30a. Substitute 3 into 1. A is equal to negative 0.0136. Substitute A equals to negative 0.0136 into 3. B is equal to 0.408. Hence, the possible quadratic function is y equals to negative 0.0136 times 2 plus 0.048x. Substitute x equal to 15, y is equal to 3.06. Step 5. Refining the mathematical models. For this model, we assume that the river is the deepest in the middle. This may not be true for some other rivers. A new model will be needed if we have a new assumptions. The answer will be more accurate if more data have been collected. Step 6. Reporting the findings. We must write a full report following the above modeling framework structure.
This is all of my presentation. Thank you for watching.